So our inputs will be our reach and output will be wire. Because we don't care about wire, we will just observe this wire or Y in our waveforms or in our terminal, but we want to store our inputs. We mostly focus on our inputs. We are mostly focused on stimulus in that part of way, that what are we giving, at what interval we should give. I will show in this testbench. Fine. Okay. Yeah. See, here we are using A and B as a reach and wire as a Y, and this is our top layer. Testbench is our top layer. So this testbench doesn't have input output. Why? Because it is giving inputs. We are storing inputs and giving this to our DUT, and this is the top layer. DUT has input and outputs. Testbench doesn't have input and output. So here you can see only the declaration of testbench signal is there with the help of data type. Module and module will be same, and as I said earlier, it is a top module, so there is no port. This is top, and inside that we will instantiate our DUT and instantiation name of DUT and that original DUT name. Let me show you this AND gate, and after that a simple name whatever you want. Then dot A means dot A of this DUT and this A which we are giving the name A. So simple for others also. And if you want to write a positional mapping for that, for example this, then you have to match the position of this module. For example A, B and Y. So you cannot change the order. Then you have to give like A, B, Y. But in positional mapping you can change, like you can write this one first, anyway, because connection will be proper, because we are giving his instruction that A dot A will be first, that DUT signal, and your testbench signal. Fine. So this is our positional mapping, and this is our named mapping. And now we will apply the signal as initial block. We are applying the signal. This is also not synthesizable block. And monitor, this is our system task. I will create a separate video after this video for our monitor or system task video. So monitor will just monitor all the inputs A, B and Y, what is happening to that input at what interval of time. Okay, and we are giving A as a 0 first, B as a 0, and after 10 nanosecond we are giving A this, B this, then after 10 nanosecond after A this, B this, and this all signals we are giving to our A and B. So these inputs will go to our A and B, and then DUT, and then DUT will process these input, and that we will get in Y, and Y we will absorb this input with the help of our monitor. So this is our simple testbench. So we will create more testbench and more of this practical kind of thing, but for that we have to complete the theory part. So for next video I will complete our system task and everything. So thank you, and comment me for any other topic you need.
Please Lord, give me a sign, a sign.